right, everybody. Hello, and welcome to the presentation from Axel Biernat on building a FHIR API for an EHR. Axel, if you're ready, the floor is yours.
Thank you very much. So as you see, I will talk how we build a FHIR API for our very own EHR, i.s.h.med. And before we're going into that, I need to take care of the legal stuff quickly. Let's pause a moment here. I think you have all seen that now. And let me speak a bit about myself. So I'm working in product management and Oracle Cerner for our EHR i.s.h.med. But beside that, I have also some other side activities. So I'm working for our industry organization, the BVITG in Germany, as a chair of the interoperability work group, and also collaborating with the standard development organizations in Germany. So HSF in Germany, for instance. So you know Simone working there quite intensively, and also Sylvia, our chair or incoming chair. Let me start to talk a bit on what is i.s.h.med, maybe not so well known for all of you. So some key facts I put here together. We are an EHR solution that is mostly used in Germany, in Austria, a bit in the Netherlands, actually, but also in LATAM and Asia, not so much in the US. So in the US, Oracle Cerner has another product, which is Millennium. And we have quite a strong footprint, and the solution is built on top of the SAP product, the SAP ERP product. So, and you see that a little bit on the right-hand side, that there is a split of the capabilities coming from SAP, so more the logistics side, the financial side, and we're taking care of all the clinical parts here. So this goes from clinical documentation, but also order entry and all the rest of that. That's a bit the starting point for us, and why we started that endeavor. So first of all, we strongly believe we need to have for our EHR an API to access all the data, to push data to the EHR, but do this in a way that's not proprietary. Basically, that was one of the challenges, but we come later to that. We have also, as part of our way of doing business, a strong ecosystem developed. So we have quite a set of partners adding value to our platform. And in the past, they pretty much relied on non-documented APIs. So, which is a bad thing if you're considering that i.s.h.med has become lately a medical device regulated product. So that brings you into hot water. So we need to change that. And also a topic we very much support is the FHIR principle, so that you can take data which was entered in healthcare for research and leverage that and advance human medicine at the end. And at the end, then we have also a bunch of regulatory topics we need to cover as well. I should mention that, very important. So first of all, we have in Germany this Hospital Future Act, which is like a 4 billion euros funding, which should boost the digitization in healthcare. So there is an implementation period until the end of next year for that one. And in the funding guidelines, it's a very strict requirement that you should leverage interoperability standards such as FHIR to build these solutions for that one. Another topic I think was mentioned here and there on the DevDays already is i.s.h.med, which is an API, a FHIR API for systems in hospitals. So of course, we need also to get an attestation for that one. So that is something we're doing with that product as well. And lastly, as we are now a medical device regulated product, class 1, we need to have that so-called channel of interoperability so that there is no issue when a partner, a client, builds a solution that accesses data in the EHR. Otherwise, this is becoming, from a legal perspective, a modification of the medical device. And so you becoming the manufacturer of that one. So a very sensitive or very problematic issue in running an EHR so far. So, but there's always a challenge. So what was ours? In our case, i.s.h.med has an, sorry, we have a pretty open data model. So think of that we have only in Germany 2 configurations that are standardized, which is diagnosis, so ICD-10, and procedures, which is OPS, a bit of an ICP-M-based system. But for the rest of the system, pretty much of the configuration of the master data is different on every single site. So wow, that was one challenge. The other is that the technology platform allows a lot of extensibility. So in 2 ways. So first of all, we have processes implemented in the product. So let's think of an admission process or an order entry process. And there are particular call-up points where you can plug in business logic, which is specific for that only client. So at the end, this led to a lot of custom development. And the other point is, as the platform is quite open, clients also did a lot of complementary features. So created like additional data storages on the same platform, added features we don't have in the EHR. So I have one client where they have implemented support of dental medicine, which is not the scope of our product, on the same platform. So it's a bit out of sight for us on the product level. On the side, of course, it is. So a key point here, the key learning is we have a lot of varieties and how to address that. Now it's getting a bit technical. First of all, the first decision we had to make whether we build a facade or whether we build a very dedicated FHIR server. Our approach was to say, okay, we have a lot of existing access control mechanism, auditability features, etc., in the EHR. So we want to stick to that so that there's only one single source of truth for our data. So you see this here, a bit of access control, this box, and RAL, which is an audit feature, so that you can see who has seen data at the end. So basically, it means the EHR remains unchanged, but what we do, we build a facade, and that's the box to the left. And here we came up with the plan to build this in modern technology, so in containers, Kubernetes, and I think that was quite a good approach. The next decision we had to make, how we implement the endpoints for the API. And I think Graham talked on that. Yes, his perception is more one endpoint. I have not fully agreed to that because I see a lot of variations if I go to various countries. So in this graphic, I have an general purpose international API, but also a German one. And a German one, we have additional identifiers, for instance, Germany specific implementation guides. But at the end, the point is, we need to, if we're doing a search by an identifier, we have to look into different database fields. So which means that the implementation is different quite a lot sometimes. And so our approach here is that we have by major release of FHIR and target market a very own endpoint. Therefore, you see here these two in the graphics. So the Germany endpoint for R4 and for international. And if we're going to build one for Austria or for R5, 4B, whatever, there will be additional endpoints. However, it doesn't mean that we copy code. We have a very smart way in reusing that. So a core implementation, which is then advanced for Germany so far. The next topic we have, so FHIR has the concept of identifiers and IDs, but we have quite some variations also for our very own identifiers in the backend. And to link these, we have built the identifier services, which basically maps the two. So and this is not only saying the ID of a FHIR resource mapped to a particular business key. We have also more complex scenarios, for instance, the encounter where we don't have an equivalent concept in our backend. So we have the combination of basically the revenue cycle perspective and the actual visit. And this needs to break down to really map to the equivalent encounter concept. And this is also what we can do on that identifier services. And lastly, terminology service, which is a quite important component for us, because here we're doing a lot of the translation of the proprietary concepts which exist in that client side EHR to a FHIR concept. And here we partnered with CSIRO. So we're using here the Onto server as part of that product to do all of that. Basically, that's a no-brainer for us. The Onto server, that was one of the easiest part to do the implementation. And then a little bit more subtle appearance it has here, the tenant configuration that basically is used for the routing when we talk to the API, because usually in a large client setup, you have multiple EHRs running, whether for the purpose of development and testing, production, but also in one system, you can have multiple facilities running. And that's basically for us, the tenant, so that we can point this API to the right backend system. But enough of that technical side. Let's go deeper into the terminology. So, which is, I think, one of the key elements for success. A very simple explanation how all of that works. So we have left side an example of our data model. In this case, we have the catalog for our allergies. And what we do is a translate operation on concept maps. And so this will give us a result what it means in SNOMED. Okay, that looks very, very simple on that diagram. But actually, there's a lot of hard work behind that. I'm not sure whether this is very well readable, but let me guide you through that. First of all, what we need to describe, the first task we need to do is to describe our data model. So And we have there a wide variety. So we have database tables. We have something like enumerations. There's a different name for that one in our technology. And we describe these as code system and value sets. So that is what a little excerpt of an Excel sheet looks like. So you have here description and the canonical URL and the OID for that one. The next step then is to make this available for a client side when we transform this to code system and value set. So they have some tools already developed, but I'll permit that step here. We do an transformation, or basically it's a deep copy for a client. So the idea is here to substitute from the canonical the root of that URL so far with a client-specific part. And then all these code system value sets will be loaded with the data from the client. And then the mapping work starts. There we are not at the end how to improve that. So there's a few more ideas we punching around to automate that. So to minimize the effort of human labor. At the moment, it would be probably a lot of human labor. So whether in tools or Excel sheets, but we should really avoid this. And coming back to basically it's just an verification step by a human being, but all the work before should be automated. That's where we're heading towards. So if we're now looking, as a bit of an end-to-end process, so how we come from a specification to a product delivered, let me guide you through that on that. I think it's a very comprehensive slide.
Have to make it short. We have 1 minute left.
Oh, I didn't saw that. Sorry.
That's okay.
I will rush. So taking the standards developed from HSM and Gematik, we have quite intensive work in doing a specification here. That's the team I'm leading. And then also doing specifications for FHIR in shorthand. And then all the implementation work starts with some usual suspects here. Some hassle we still have in the testing area. So where we're maturing together with Gematik, the tooling for the attestation. And then at the end, delivering the product. So for the sake of time, I cut here. If you have any more questions, feel free to come back to me, then we can go to that. There is quite some learnings I brought here. Unfortunately, cannot share that any longer. Then.
Excellent. Thank you very much. I'm afraid we do not have a lot of time left for a Q&A, but like you said, if you have any questions for Axel, please look him up in the lobby and go out and talk to him. Axel, thank you very much for your wonderful presentation. A warm applause.